Good morning, everybody, and a very warm welcome to this Sustainable Development Energy Savings in Steam Systems webinar presented by Spirax Group. I think before we get to the introductions, I would just like to go through some housekeeping rules very briefly. So let's just have a quick look there. So the first one is that we will try and keep the presentation to about 50 minutes, which leaves us with about 10 minutes for Q&A at the end of it. We will, of course, record the session, so everyone on the call will have access to it for later reference. Everyone's microphones are muted, but if you do put up your hand and you want to come off your microphone, we can allow for that, so you can ask the question. You don't just have to type, but of course also feel free to use the chat function to submit any questions that you may have as we go along. For those questions that we didn't get to during this session, we will try and get back to you after the session as much as we can. And after the session, there will be a sort of a survey. So if you wouldn't mind just adding or taking a minute or two to just give us a little bit of feedback so that we know what to improve on for the next webinars, etc. And just before we get started properly, if we go to the next slide, there is a QR code that I'm going to ask everyone to just scan with your phone. Alternatively, in the chat, there will be a link that you can use to take you to exactly the same survey. If you could, please just, as we carry on, just start filling in some of those questions. We'll appreciate your feedback on that as well. And as we carry on, we'll refer back to some of those answers there. So let's get to a quick introduction. So for today's session, we see Nick Wisby. Nick is the Technical Engineering and Sustainability Driver for ESA, Eastern and Southern Africa. He's been with the company for nearly 9 years, and he's worked in all kinds of departments. For example, he's worked in our green tech team, etc., etc., etc. Together with Nick, we have Aurea Soleil, and just a quick bit about her. She's the Sustainability and Business Development Manager at the Center of Excellence for Sustainability in EMEA, or Europe, Middle East, and Africa. She leads the initiatives focused on the decarbonization of steam systems across diverse regions, and she collaborates very closely with us, the operating companies, and our local teams to support you, our customers' needs. Finally, myself, I'm Cornelius Schenk. I'm the Head of Sales for Eastern and Southern Africa. I've been with the company about 11 years, based in Durban. Nick is based in Kenya, and Aurea is based in the UK. So it gives us a bit of a flavor of where everyone is from. So again, we thank you very much for joining us today. And let's just go into the agenda and just see what we're going to be talking about a little bit for today. So today we are going to just look at Spirax Group, the group, who we are, where we are, what we do, that sort of thing. Then from there, Aurea is going to take us through the energy outlook in industry. We're going to look at a little bit of optimizing steam systems, because that's where the biggest bang for buck generally is. We're going to look at MMT, metering, monitoring, and targeting, or how we manage our steam systems. Then we will look at some of our target zero products and systems that we have and are developing, after which we will stop off at the Q&A. This is the first in a series of webinars, and as time goes along, we'll invite you back for some more, and hopefully you can join us for those. Right, so who is Spirax Group? So the Spirax Group consists of three companies. We've got STS, Steam Thermal Solutions. And Steam Thermal Solutions consists of Spirax Group, our Gestra brand, Hightech, Cotopaxi. These are generally companies that manufacture products, services, and digital services for the steam industry. Also have our Electric Thermal Solutions, which includes all those companies that you can see there. And these are the companies that, as part of decarbonization, electrification is obviously something which is becoming more and more popular. We also have a fluid technology systems company called Watson-Marlow, and they have all those brands as you can see on the screen there. And all three of these companies, your Watson-Marlow, your Steam Thermal Solutions, and your Electric Thermal Solutions, is the Spirax Group. And the Spirax Group is a FTSE 100 listed company. We have been on the London Stock Exchange since 1976, and in 2018 we went onto the FTSE 100, which means one of the biggest companies or one of the top 100 companies in the entire United Kingdom. So where is Spirax Sarco? If you look at where Spirax Sarco is based, all the dark blue is where Spirax Sarco is. All the dots is our manufacturing facilities. And then the gray bits are where we have a presence in, but not necessarily an operating company. And so we've got 146 operating units, more than 10,400 people across the globe. We have 2,100 sales and service engineers. We're available in 67 countries. So it's a fairly large multinational company, and we are available pretty much everywhere that people use steam and engineering fluids. Right. So if we look at what it is that we do, we are a steam thermal solutions company, looking at not just steam traps, because there is a bit of a conception that Spirax Sarco only sells steam traps. But if you look at this diagram on here, we've got products that goes for the entire steam and condensate loop. So that goes from boiler controls, level controls, alarms, etc., and the steam generation side. We've got flow metering, control systems, pressure, volume, temperature. Of course, a whole range of steam traps, and steam traps is by far our biggest product range. We also have condensate pumps and other other mechanical fluid pump type products. We have thermal energy solutions, which goes from exhaust vent condensers, thermocompressors, etc. Pipeline ancillaries, humidification products, compressed air products. We also build our package systems depending on where you are in the world. We can get package systems. The picture that you can see is a packaged heat exchange system, which is essentially a plug and play system. That's pretty much in a nutshell, very briefly, what it is that we do. If we then go to our own Spirax Sarco, of course, as a responsible corporate citizen, also have our own decarbonization strategy called One Planet. Our objectives and our deliverables are in these diagrams here, but to give you a flavor, it very much falls in line with the UN's 17 SDGs, and this is what our company is working towards as well. And of course, we're not just talking the talk, we also walk the walk. So if you look at our One Planet in action, the sort of thing that Spirax Sarco does, is we have our energy savings initiatives, we have our biodiversity initiatives. Our energy saving initiatives is just really for our manufacturing facilities to decarbonize ourselves as much as possible. In the UK, and even down into the operating companies, especially Kenya and South Africa, the offices there have gone into solar quite heavily, simply again to help help decarbonize the planet as much as we can. And we have our target zero solutions that we are developing to help our customers, of course, to decarbonize their steam systems. Steam in and of itself is carbon neutral, but the generation of steam, the energy that we require to convert water into steam, that is obviously not always a net zero. But we have some solutions that can get us at least somewhere there, and at least to decarbonize the steam system. Of course, we'll never be able to decarbonize an entire plant, but at least from a steam generation point of view, we can help with that. And steam is still the most effective heat transfer fluid that's available. The physics about steam doesn't change. It remains an incredibly effective method of transporting thermal energy from one point to another and use it and get some of that energy back in the form of condensate as well. Very safe, very effective, and of course we want to just help decarbonize the generation thereof. But as you'll see through today, there's no point in trying to decarbonize something if the steam system itself isn't as optimal as it could be. And so we're going to really be talking a lot about optimization of steam systems today. All right, Maria, I think that's my bit. It's over to yourself now. So thank you, everyone. Enjoy the webinar, and please feel free to engage with your comments and your questions.
Great. Thank you very much, Cornelius, and thank you everyone for connecting to the webinar today. It's a pleasure to have some time to go through what we can do from Spirax Sarco. But before we dive into the specifics of STEAM system, let's take a moment to understand the broader energy landscape and why this conversation is so critical. So what you can see in the slide, globally, heat is the largest end use of energy, accounting for nearly 50% of total final energy consumption. So that's more than electricity and transport combined. Yet, despite its scale, heat remains one of the most overlooked areas in the energy transition. And indeed, it's responsible for over 40% of global energy-related emissions. And here's why industry comes into sharp focus. So industrial processes consume around half of all energy used for heat. And this is where our industrial plants come into the picture. So this means that industrial heat is not just a challenge, it's one of the biggest untapped opportunities as well in the fight against climate change. While much of the global attention right now has been on maybe decarbonizing electricity and transport, the decarbonization of heat, especially in industry, is now emerging as a strategic priority, as we all see around. Now that we have seen how heat dominates global energy consumption and emissions, let's shift our focus to Africa, where the energy landscape presents both unique challenges and powerful opportunities as well. So in Africa, as you can see in the slide, industry plays a central role in productive energy use. According to the Africa Energy Outlook, that's the report we took the information from, industrial activity is one of the fastest growing energy consuming sectors across the continent, and this is driven by expanding manufacturing, food processing, mining, all which rely heavily, obviously, on thermal energy, and particularly steam. Unlike residential or transport sectors, productive uses of energy, like those in industry, are directly linked to economic growth and job creation as well. But it also means that inefficiencies in industrial energy use translate into lost economic potential and increased emissions. So steam, as a flexible and efficient heat transfer medium, is already deeply embedded in the African industry. From food and beverage to chemicals and healthcare, steam powers essential processes. And the challenge now is how we can modernize these steam systems. So as we have seen, it's very versatile still and widely used in heat transfer. But what makes steam stand out compared to other industrial heat technologies, such as thermal, oil systems, or electric heating? Thermal oils can handle high temperatures but require complex infrastructure, higher maintenance, and pose environmental risks if leaks happen to occur, basically. And on the other side, electric heating offers precision, but it's often costly at scale if we are dealing with a project. It has high capex. So steam, on the other hand, is efficient and controllable and can cover a wide range of different temperature applications in the industry. This combination of flexibility, efficiency, and sustainability, as we can treat it as a closed loop between the steam and condensate loop, this can explain why this is still the backbone of industrial thermal processes right now, like food, beverage, chemicals, and pharmaceuticals, as we have commented. Okay, so we have spoken about energy and emissions a bit, at least provide the context, but let's turn to another major environmental threat, which is the water. Water scarcity is one of Africa's most pressing sustainability challenge, and many regions are already under severe stress. As you can see in the image here, projections show that this will only intensify dramatically, as in many other areas around the world. So this will surge, making efficient water use critical also for industrial resilience at some point. Industries are responding to this. So, for instance, Nestlé has implemented closed-loop systems and water reuse strategies in African plants with the aim to minimize freshwater withdrawal. And on the other side, for instance, just to provide another example, Coca-Cola invests in water replenishment projects aiming to return to nature, basically, and communities an amount equivalent to what they use in their production sites. And really, these actions just demonstrate that sustainable water management is essential for business continuity, as in steam systems can play a role too in this by recovering condensate and reducing water losses. We are mindful that we have to align with this environmental threat as well. Okay, so going to the results you have shared with us, let me switch here. You should be able to see it. Can you confirm, everyone, that you can see my screen? We have only, yes, thank you, Debbie. We have only had some responses, but this at least can provide us a representation of our audience today. We have asked, what does your company have formal sustainability goals? We can see that 25% have answered that no formal goals yet. In some occasions, we do have sustainability goals, but not yet related to steam production, and 50% of our respondents have linked their sustainability goals with the steam production and steam system. Okay, so we will deep a bit into that in today's presentation and how we can link some of the solutions we offer to reducing these KPIs. On the other side, we have asked what's the biggest challenge in improving steam system. That's a live poll, and I'm seeing that more people are answering. The first one, and well, actually, it's in pair. The first three ones are lowering energy use. That's the biggest challenge. Cutting CO2 emissions. Probably this is a challenge if you have sustainability targets. So that's going aligned with the previous question. And as well, budget constraints, which we acknowledge that's almost the biggest challenge in absolutely every plant. The good news is that we can link the three of them together in some of the optimization solutions we can offer. Water consumption, and as we have made reference to in terms of reducing water intensity and lack of technical expertise. This is where we would be very much willing to provide support to. Lowering energy use is still the first one, so it's going online. Okay. And latest, we have asked what kind of support could we help you in improving steam system sustainability. The first ones are technical training, as the webinars we are running right now, return on investment case studies. That's indeed something we can develop for the optimization solutions we can offer, on-site audits, digital tools, and peer benchmarking. We will cover those today, but thank you very much for the ones that have answered the polls. That helps us at least shape a bit as well the presentation to match your needs on what you're looking. Proposal, or what's the framework that we suggest all our customers to follow when we are looking at the roadmap to net zero in steam systems. And we divide it simplifying in three different steps. The first ones are optimize and manage, which are the ones you can see at the first and second pizza bits here. These two steps are very much focused on improving steam system utilization, improving the energy efficiency, and reducing the carbon emissions by providing the expertise and knowledge we have and what we see that is happening in other steam plants, as well as applying digital tools so that we can understand what's the dynamic of our steam system, what's the behavior, and we can really see at what points of the energy systems we have inefficiencies. And as latest step, when we have reduced our emissions, it comes the decarbonization stage, which is we want to eliminate 100% carbon emissions by changing the steam generation technology. And why do we say this is the latest step? Because if we had to change our steam generation technology today with the steam systems we have, probably it would be incredibly expensive, significantly oversized. As for what we see, there's huge potential in lowering emissions by only looking at optimization solutions. And not least important enough, these technologies are maybe not really mature yet and would require a high knowledge of your steam system to do a tailor-made. There are technologies, and we will expose you some of them, but this is very much evolving in the market as we speak. So let's go to the first one, which is optimization and our view on how we can support you in that. This is a Sankey diagram, but it's very representative of an average steam system we have. We can see here that from the fuel inlet at the very beginning of the steam generation point here, through the distribution of steam until the point that we are making use of steam heat, basically, we can lose up to 40% of the energy by generation loss. Only 60% of the energy contained in the fuel inlet, in the fuel we are using to generate steam, is going to the direct use at the process. What this tells us is that there's a huge potential to reduce this percentage. Again, that's just a representation, and it will be very much dependent on how frequently and how much you are looking at continuous improvement in your steam system. But this provides us with some percentage or numbers or ideas on where we can focus for the optimization opportunities, which is a generation, boiler house, basically, and distribution losses. And among the many different optimization solutions we can identify, and that will be very dependent on your steam system, we have a total of 5 that are like fundamental and are like the backbone of any other later step we want to take on optimize, manage, and decarbonize. And these are the ones we see regularly in our customer sites. And that's why we have grouped them in the top 5 optimized solution that we should start looking at as soon as possible if we are not yet looking at them. The first one is steam metering. It's the first step to optimization because before we can improve the steam system, first we need to understand it, and that starts with measurement. Steam meters provide us with visibility as well as accuracy, and help us uncover inefficiencies that would otherwise remain hidden probably. So by monitoring steam usage, we lay the foundation for long-term energy management and continuous improvement. In fact, adding steam metering and monitoring can reveal significant opportunities to lower energy consumption. And that's statistics taken from our global audits. We can uncover up to 10-15% energy saving opportunities by only looking at that and spotting them, basically. So it's a simple step, but it's the key that unlocks smarter decisions later on. The second top solution that we suggest looking at is steam trap surveys. So plants that periodically check their steam traps regularly, the percentage of leaking traps can be less than 5%. But those plants without a frequent steam trap check plan, let's say every 6 months, yearly, we can get the steam population failing up to 20%. And just a single failed open steam trap, that's obviously average, but can waste up to $1,000 per year. That will be very much dependent on the steam pressure at that line. That will be very much dependent on the steam generation, but that's just a rough estimate for you to see that that's significant, the potential to and the impact we can reduce. For that, we offer a service which is steam trap survey, where we have a health check of the steam trap population, and we provide a report with the executive summary of how the steam traps are working, basically, and which of them need to be replaced. In some occasions as well, we see that the model of the steam trap that is being installed at the point of use is not the perfect one, let's say, and there's other models that could work better at that point. That's also a thing that we add suggestions for better placed models in that point. The third optimized solution that is fundamental for us to look at is insulation. Insulated lines, insulated components, insulated equipments can reduce energy losses by 90%. Indeed, any surface above 40 degrees, that can be a steam line, whether if it's at 10 bar, whether if it's at 5 bars, whether if it's at 3 bars, as well as condensate return lines, because they are as well radiating heat. And this is just a rule of thumb. Typically, the payback of installing insulation jackets can be under 1 year. So it's a very quick win optimization solution. As you can see here in the image, there's just 2 examples of insulation jackets that we offer to our customer. That's an insulation jacket in the steam trap condensate drain, as well as in a heat exchanger package. If we move to the fourth top optimized solution, we always suggest our customers to look at, and we help them calculating as well the energy savings, is returning the condensate. Condensate is valuable energy, and condensate recovery saves money as well as energy, because it contains about 25% of the energy from the original steam. So returning this condensate with sensible heat to the boiler feed tank reduces fuel use directly. We have the rule of thumb that by increasing the condensate return flow by 10%, this can mean up to an average 1.3% reduction in the boiler fuel consumption. So not only energy and obviously cost reductions here, we are as well reducing water consumption as well as chemicals and effluent costs. Why is that? Because reusing it, we don't need to treat it again, adding the chemicals into the treatment operation in the boiler house, basically. So finally, recovering the condensate helps as well eliminate visible steam plants, improving your site's environmental images. And speaking about steam plants, we move to the latest optimized solution that we always suggest to look at, which is flash steam recovery. In this video that you can see here, there is a leak of 20 kilos per hour, continuously leaking into the atmosphere. And we have estimated with a typical operations that you can see here at the bottom. So this is steam at 10 bars. We consider 80% of return, operations of 5,000 hours per year, and considering a natural gas boiler of 90% efficiency with an average cost of steam $30 per ton. Having this continuous steam leak at the end of the year, we would generate a cost of $3,000 per year, which would emit 12.9 tons of CO2 emissions per year, and would generate a waste water of 100 cubic meters per year. Okay, let's look at another steam leak, which is 70 kilos per hour. And with this, what I mean is that most of the times when we have steam leaks, we don't even know what's the flow that is getting released into the atmosphere. But let's look at the jump in terms of sustainability and financial impact between these two cases. In this case, we would be wasting $10,000 per year, and we would be consuming and leaving to the atmosphere an extra 350 cubic meters per year. And that's where we say, let's try to recover the heat that we are releasing to the atmosphere by means of an EVC, that's a heat exchanger that we have, and reuse this energy at any other point in your plant that this can be recovered and properly placed. So these are the top 5 optimized solutions that we suggest to start from. Basically, there are many. For each of them, what we can do is we can provide an estimation of what's the energy savings, what's the solution that we propose, because we have equipment and components for recovering all this energy. And these numbers that you can see here are the savings resulted from steam optimization solutions that we have provided to our customers during 2024. That's not something that we have estimated. That's something that a third party consultant has calculated for us. And we can see that the savings and the environmental impact that we can provide are not low. It's significant. And this is as well resulting in our scope 3 emissions. So we have interest in supporting you develop as well through your roadmap to lower your energy as well as your carbon emissions in the steam system. Again, I have provided the top 5 optimized solution, but we as well have a service team that conducts energy audits in the steam system. That's just a snapshot, a screenshot of the report of one steam system energy audit that we conducted, where we can see that we start from the base case scenario, so how the steam system works in our customers and what's the energy consumption. We provide a set of optimization solutions, suggestions, basically. And if all of them are applied, we would get to a future baseload energy consumption. We as well compare that with the return on investment of this optimization solution, as well as with the sustainability metrics of what's the sustainability impact that each of these solutions can generate. And that's from my side. Now I will hand over to Nick to cover as well the manage and decarbonize bits.
Thank you, Aurea. So yeah, welcome everyone, and it's a pleasure to see you all. So we end up on the metering section, the decarbonisation section, moving forward. So we're on the manage section, so the second section on the wheel. To Spirax, as Riz already mentioned, the beginning sections, optimize and manage, are most important because we want what you have to be working most efficiently, so it's cheapest for you to run. Then when we get to that stage, we can look more at the decarbonisation. If you move to the next one. Next slide. Thank you. So what do we say what do we mean when we say manage? So we're talking about monitoring your system and looking for leaks in real time. So if we take an average site, let's say a small to medium site has 100 traps, it probably has a lot more than 100 traps. Probably takes your engineers about 15 minutes to inspect each trap. That's 1,500 minutes just to inspect 100 traps. Now, when it comes to monitoring, we offer systems that allow you to monitor them in real time it's effectively a sensor on top of the trap or the heat exchanger or wherever you'd like to place it. We can then connect that to a web-based system, so a cloud-based system, which real-time monitors your traps and tells you when they fail. So instead of waiting that once a year or that once every 3 months or whatever your schedule is, you will know instantly or almost instantly when your trap has failed. So it allows you to be very specific and very purposeful in your maintenance. That in turn saves money. So if you have a trap that's leaking for a week before it's been seen, that's cost you 12 kilograms of steam per hour. If you see the trap has failed within even an hour or so, the losses are considerably different. So we have many different ways of also doing that. So we do connected hand tools. We have connected hand tools, so our engineers, when they can perform a steam trap audit, can go to site and they can monitor or they can look into your traps and see if they are failed open, failed closed, if they're working properly. And they're actually tagged, so they're tagged with the date they were inspected and when we presume that you would need to inspect them again. That comes under the expert audit, which is on there. I've just noticed I don't think I have a pen that I can use. We have sales staff, expert sales staff. So all our sales staff are engineers. So we may be selling, but we're selling with authority. We know what we're selling you and we know why you need it. Experts in the field, so our service teams, as previous slides have shown, Spirax has a presence almost all around the whole world. You are never further than a phone call away from an engineer to a service engineer to come out and see you. And then we have the connected system, which I've just touched on. So the Strata system, we call it a Strata system, a cloud-based system for real-time monitoring. That allows you to do connected audits. So you can monitor that data. You can extrapolate the data to various different things that you need and be able to tell you, for instance, your water loss or your water usage or how often a heat exchanger was stalled, so flooded or so not working correctly. Many different ways to extrapolate that data. Connected sales again. So if we see a steam trap failing, then we can tell you how to repair it. For your information, if you take a steam trap, let's say it costs $100, brand new. I know that's unlikely. It's probably been a long time since one cost $100, but to service it, for the service components from Spirax and many other companies in the same industry, is around about 30% of the cost. So you're making a 70% saving by just repairing what you already have. So we then on a connected field. So because our engineers can see the Strata system, because you can see the Strata system, we can actually be in a position where we are working in a partnership and telling you where you may have some issues and liaising with you to deliver a service that allows you to fix it as soon as possible. Next slide. So digital services, so I touched upon this before. So the service and audit, we have the diagnostic kit. So we have a kit we can put on your heat exchanger or on your traps, on your meters, on various different things, and diagnose if they're working properly. I will also tell you the steam loss. So it's a steam loss quantifier. Product monitoring, again, it's back to what I was talking about with the strata system. We call it the Eco Bolt. So it's a sensor in the image, a trap, which then goes off to a transmitter box and transmits to the cloud and tells you your status of your trap. Package monitoring, so all those sensors can be put on our packages. The item that's shown there is a heat exchanger unit. So we can also monitor that system, and you can also see that system when it's working properly, what percentage is working efficiently, and so on. Flow metering, we can put strata on any meter. It doesn't have to be one of ours, but we can meter your fuel, your water usage, your steam usage, even your effluent out. So you can have a real-time look at your losses on your usage, your efficiency of producing steam, so how efficient your boiler is by metering your solution properly, so metering your production lines and your steam lines. And system monitoring is kind of what we've just been over. That's more for the boiler controls, thermal batteries, which we'll talk about later, which is one of our decarbonisation solutions, and site-wide monitoring. So it doesn't matter if you're sat on for my Kenyan colleagues here, a matatu there on your way to work, or if you're sat at your desk, you can still see what your steam system is doing. It's viewable on phone, tablet, computer, you name it. If it's got a screen, you can see it. Next slide, please. So wireless steam trap monitoring. So how it works is there's a sensor, as it shows on the trap on the left-hand side, and then goes to your transmitter box. That's picked up by, I think that might be in Spanish, but it's picked up by a router, which then transfers it to a computer system and then onto the cloud-based system. So it's a little bit more difficult on that because it's in Spanish and I speak only English badly, so I apologize for that. Next slide, please. So as this shows, because of, okay, yeah. So steam insights, so heat exchanger performance. So as we were talking, if you monitor your steam heat exchanger, there is a point on most heat exchangers, unless they're very well installed, they reach stall. So what we mean by stall is if you have a control valve before a heat exchanger to control the flow of steam into your heat exchanger, to control the heat, at some point that will close. When that closes, the steam that is downstream from there collapses and pulls a vacuum. That allows water to build up in the heat exchanger, which means that you then get less efficient heat systems. And the other challenge with a flooded heat exchanger is that the expansion of steam and water is different. So many of you, if you've got a heat exchanger on site which keeps on popping gaskets, it could be because it's flooded. So what that does is warp the plate in different temperatures, different rates, and ends up buckling and eventually breaking the gaskets in between the plates. So we can put a sensor on there, which will then tell you how efficient your heat exchanger is when it's entering flood, if at all. And by doing that, we can extrapolate the costs. So how much that heat exchanger is actually costing you to run. For instance, there's an example at the bottom kind of middle part of the slide where it's telling you the energy savings by making sure that heat exchanger is running efficiently, how much tons per year you're saving by making sure that heat exchanger doesn't enter into flood, and the financial costs. So that's in euros, is very similar to dollars, euros. So you can see the savings that can be made. This will also fit on our automatic pump traps, so our APTs. So they're mechanical traps. Many of you may have seen the APT or the MFP on site. The image that is on the right-hand side, the blue kind of oval-shaped item, is actually our MFP. So that's a mechanical pump trap. Next slide, please. So connecting to easy heats, as you can see on here, there is a example of what you would see on your system. UK made, so these are made in the UK and connected, a UK seafood manufacturer connected and installed the easy heat. So they connected all the sensors that we've just been talking about and the digitization. Remote diagnostics identify energy savings and prevent premature wear. So the wear on the heat exchanger is being cut because the maintenance is less, because you can tell when your heat exchanger is running properly, and when it doesn't, you can change what you need to change. Water loss is detected on closed loop system. So effectively, anywhere that there was a leak, anywhere that there wasn't a return, it was monitored, sent back and rectified. And there was a water leak discovered and rectified in the factory. So it found where there was it showed you where there was a leak coming through the system, allowing you to save that water and bring it back to where you should do, which is your boiler. The reason why that condensate is so important to return as much as possible is, as Aurea said before, it's treated, so it's already chemically treated. It's relatively pure. So the more you can get back to your feed tank, the more you can go put it into your boiler, the less top-up water from maybe a borehole or a water source. Therefore, you don't need to retreat. You're saving on chemicals, you're saving on energy because there's heat there, and you're more efficiently running your system. Next slide, please. So now we talk about the decarbonisation. This is very much the end of your journey, and I want to state that properly. The places you will make the most savings will be optimize and manage. Decarbonisation does save money. It saves money on net zero, on the emissions that you're putting out. But these are designed to replace the way you generate your steam and connect to your existing system. Next slide. So as it puts here, we don't want to waste the energy that we're creating in electricity. So if you take the example here for CapEx, a 1.4 ton an hour steam system will require about 1 megawatt of installed power capacity. So an electric boiler will use around about 1 megawatt per 1.4 tons. I think it's pretty even. So I think a 10 megawatt boiler will do about roughly just under 10 tons. 1 megawatt of an additional installed power capacity costs between 290 and 570 USD. So that looks like it's, yeah. Operating 1 megawatt, an additional installed power capacity during 1 year, so 6,000 hours, would require 850 USD per. So are these figures are in hours?
Yeah, it's US dollars as an equivalent, an average.
Okay. So yeah, you can see the costs that are involved, and that's why we want to make your system as efficient as possible. The less steam you're using, because you've rectified leaks, because you are using what you have more efficiently, the smaller your electrification boilers can be, if that's the route you choose to go. I know East Africa, from my experience of being here for almost 2 years, it's mostly biomass. But even biomass is not green, it's not net zero unless you have a closed loop of supply fuel. So it needs to be renewable. Next slide, please. So thermal energy consumption. So this is just showing by effectively different projects you can do, how much energy you can save. So if you, for instance, you take the first one, the replace failed steam traps. So let's save 294 gigajoules, is that? Yeah. Oh, no, sorry, 294 kilograms an hour of steam. Yeah. So insulation, again, and a saving that can be made there. While we're touching on insulation, so bad insulation, an uninsulated pipe, yeah, let's say running at 7 bar, per meter will lose around 525 watts of energy. If that's insulated, and that's per meter, by the way, if that's insulated, that drops down to 80 watts. So insulation on pipes and making sure that the insulation you have is kept in good condition can also save a lot of money, a lot of energy. So effectively, this is just showing the gains that can be made from various different optimization and management of your system. Next slide. I'm just aware of the time. So we have 4 solutions when you reach the decarbonization. So Steam Vault is a system where we retrofit an existing boiler. So we take your coal-fired boiler, your heavy oil boiler, and we convert it by taking off the end cap, welding shut the gas chamber or the fire chamber, and inserting electrical elements down the pass tubes, which converts that into an electric boiler. When we're talking about efficiency ratings, so if you take a fossil fuel boiler, it's around 81, 82%, maybe up to 85% efficient. When you're entering into electrical boilers, they start at around 91, 92%, go all the way up to arguably 99% efficient. So the Steam Vault allows you to cut the use of fossil fuels or any other fuel that you may be using to burn. Electrofit Steam Vault is the whole solution. Yeah. So Electrofit is the converting of the boilers. Electrofit is the Steam Vault is a complete solution. So we work with boiler manufacturers, many that you'll be familiar with, such as Fulton and other big manufacturers, Thomson boilers, things like that. And we can sell you an entire boiler, so it's a plug and play solution. The Electrofit is the one that is the retrofit of an existing boiler. So steam battery, a lot of places are moving more towards, say, solar energy. But the challenge with solar energy is how do you store that energy? Traditionally, the battery packs, the cells required to store that energy are quite expensive. They can be at times very difficult to get hold of in the Africa area. So what the Steam Vault does, or Steam Battery does, sorry, it's think of an accumulator with an electrical element. So it's filled with water. We heat the temperature and increase the pressure up to 20, 30 bar, 29, 30 bar, 32, and so on, depending on your system. And then when you need that steam, say that you're running a night load, which is not really high enough for you to justify turning on the boilers, or you need maintenance on those boilers, we then discharge that hot water and by differential pressure create steam. So it connects. It's very important that all of these that I'm talking of now connect to your existing infrastructure. Other than the item itself, there is no change made to your system. And depending on the size of the battery, and depending on whether it's many small ones or one large one, will give you your pressure, and it will also give you your kilograms per hour. And then we have our heat recovery system. So effectively the heat pumps, where we can generate steam from waste heat and run a system that way. These are, again, our plug and play technologies. They're skid mounted. So as long as you have the floor space for them, and we've done the calculations, you've ordered the correct unit, we then can connect it to your existing infrastructure and keep on running. Is there a next slide after that? Yes. So what we're trying to do effectively, in short, is we are trying to optimize your system. So when it comes to you having to spend the big money for CapEx on larger systems, whether it be packaged units, whether it be replacements of boilers, so on, we're reducing the CapEx expenditure. So therefore, the outlay that you need to improve your system reduces. We develop a system that aligns with your production needs. So we are not just selling for the sake of selling. I myself do not work in sales. My job is designed to try and save you money as much as possible. So where we can align with your production, where we can optimize your production, make it run more smoothly, make sure temperature is at the right place at the right time, and that reduces your costs. And again, like it says there, the decrease of operational costs by optimization and management. Increase overall system efficiency. If you're not leaking steam, you're not wasting steam. So therefore your system is more efficient. And reduce investment on carbon offsetting projects. So If you're, say you're using 10 tons an hour after you've rectified all your leaks and your process is running as optimized as possible, let's say you're using 8 tons, you've saved 2 tons of energy. I know it's a little bit probably exaggerated there, but it's just to make the point there. Next slide. So our next webinars, this is meant as an overview on us as a company and the direction we're taking, but we will deep dive into the sections that have been lightly touched so far in this webinar. The first one is in 3 months' time, so it's one per quarter, and that'd be basic evaluation or optimization of your systems. How do you do that? Advanced steam thermal audits. What exactly is in our thermal audits? Why would it benefit you? Why would it save you money? Deep dive on steam thermal energy. So when we've got that information, what do we do with it? How do we present it to you? How do we show you how to make savings? Then manage energy use and costs. So again, transitioning from that report into real-time, real-world solutions to improve your system to save you money. And then on the final section, we will work on decarbonisation. So I'll go deeper into those 4 different items that we offer when it comes to the end of your journey. And we will describe how they work, how they generate power, and how they could benefit you as the end user. I think that's me done. So now it's time for Q&A. Any of you guys, please ask questions. We love your interactions.
I don't think we have any questions so far. I don't know about the rest. Yeah. Okay.
I see a couple of hands up. I don't know how I allow them to speak. How do I?
Let me just quickly take them off. Okay, they can unmute themselves. I think the first one is Makula.
Allow mic.
Let me just try again. Makula, can you hear us? I think you are unmuted.
Oh yeah, I can hear you. It was my side, yes. So what I wanted to ask is with the condensate returning, what method would be more efficient to get the actual? Would it be the meter, a condensate meter to get the amount of condensate coming back, or using the steam tonnages, the amount of steam used produced and the amount of feed water used?
So a meter will always be the most accurate because it's real-time seeing what you have there. There is other ways. So if you have mechanical traps, for instance, there's a counter unit you can put on there, so you can see how many cycles that's done, therefore how much is pumped, because it's a set volume that's in the pump. But a meter will always be your premier way of telling exactly what you're returning, just because of the accuracy level of them. Aria, I'm sorry, I think I may have cut you off, so I don't know if you have more to add.
Yeah, no, normally that's it, what Nick has mentioned. Normally as well, in the audits, we are providing an energy and mass balance to get more or less the temperature in which we are returning the condensate, as well as the steam generation. There's a calculation being done, but that's just an estimation. It's not the accurate level that a meter would tell us, basically. And that's for the overall condensate return percentage estimation.
Okay, the noted. Thank you very much.
Thank you.
I would suggest, Makula, sorry if I'm not pronouncing your name correctly. If you need support on that, just reach out to us, and we can provide support as well in improving that bit.
Not a problem. Not a problem. Yeah, I'll reach out.
Thank you very much.
Thank you.
I see next one is Edgar.
Yes, thank you. I appreciate this webinar. I think it sheds light on a couple of things. I had about, I think, majorly one inquiry, and then a bit of an observation. I think sometime last year we bought a couple of Spirax Circle meters in our site in Kampala. That's Coca-Cola, Uganda. I think I'm just here to reach out to the team there because I was transferred to another site just to see if that is giving us the value we intended in terms of metering steam. My question is in regards to the last point that you highlighted on decarbonizing of the boiler. To the best of my knowledge, I'd always based on the flue stack temperatures to determine whether the boiler it needs decarbonizing or not. Basically, if temperatures go above 180, 180 to 200, above that, I would then sanction for decarbonizing. But I see in certain operations, you find they just put it up as a routine. And I don't know if that is actually helping. For example, if you if you do the decarbonizing twice a month, does that add value for a boiler that's running on heavy furnace oil and runs about 8 to 10 hours a day, maybe 5 days a week? I just needed some clarity on that.
So when we talk about scale effectively, so when you're decoking the boiler, any coating that slows down the transference of heat is going to lower the efficiency of your boiler system. So if we take a normal system, so if you have air in your system, air is the largest barrier to heat. It stops the transfer the highest. Scale is probably the third largest. So when you're decoking your boiler tube, you're increasing or you're maintaining the efficiency of your boiler. Ari, I don't know if you've got anything to add.
No, fine. Thank you.
So I hope that answers your question.
Yes, it does. Thank you.
And thank you for your question. Thank you for your input.
The last one up is Anele. Anele, just try to come off your mic again.
Greeting everyone. Can you hear me?
There you go.
We can, yes.
Thank you very much for an opportunity. So this is Anele. I'm in South Africa. So yeah, I was invited by Spirax as I'm right at the beginning of our project for condensate recovery. But yeah, I learned some nice new things here. We are using natural gas in our company. So I saw these decarbonizing or decarbonization methods you put there. Which one is the best for you for especially natural gas users? Especially when you look at the problems of South Africa, where our electricity is not even reliable. So within using natural gas, what would you recommend as a decarbonization method, even if it is outside the ones you put already?
So I have to be honest, before I answer your question, I'm a little bit biased because I was part of the design team of the steam battery. But to me, the steam battery is my favorite. I think it works very well with existing systems because you can have, say, several small batteries, cascade them so that as one's releasing or one's finished releasing, another one comes online, so you maintain a longer load. The advantage of them is that they can be very close to, as long as you have space, they can be very close to individual processes, which also means with being unmanned, there is a ability to release steam and take off pressure from a boiler. Say that you're adding an extra 5 production lines, then normally that would mean you'd need to replace the boiler. Steam batteries can supplement that load so that you no longer need to replace that boiler. But the way these things charge, when you come away from the electrofit and the steam volt boilers, which are electrical boilers, the steam battery can effectively trickle charge on solar power. You could use a wind turbine if you're in a windy area. It could use hydro if you have the option there as well. So it is very expensive electricity in general in Africa, comparatively. But there is other ways to source that electricity for those solutions. The advantage of electric solutions, it gives you the power back to be able to decarbonize by using green technologies. Ari, I don't know if you want to add to that at all.
Yeah, just a brief comment. I really think that there's no gem technology. It will be, I know that it's a very, very general answer, but it's really dependent on the obviously regional availability as well as the process profile. But generally speaking, it's true, and I would as well agree with Nick that anything that deals with storage is allowing you to decouple the energy consumption with your production. And this has great power in terms of being able to properly manage with, let's say, having certain level of flexibility.
Okay, thank you very much.
Thank you.
Thank you very much for your question as well.
So that looks like it brings us to the end of the session. I don't see any more questions. So from my side, I want to thank everyone for taking the time out of your day and investing that time with us today. And we look forward to seeing you on the subsequent webinars that will come up in due course. We'll obviously invite everyone on the call again, and hopefully many more. I hope everyone learned something today and found it at least a little bit interesting. And please feel free in the meantime, don't have to wait for the next webinar, but please feel free to join us whenever you or to contact us whenever you have any queries in terms of optimizing, managing, or even decarbonizing your plants. Thank you so much, everyone, and thank you to Auria and Nick for their presentations as well.
Thank you. I noticed there's a couple of questions on chat that we didn't get to. So if you can email me directly, I will do my best to answer them.
Awesome.
I've put my email address in the chat.
Great. Thank you, Nick.
Thank you very much, everyone,
Thanks, everyone.
for your
Thanks, Debbie.
participation.
Thank you.
Cheers.